So you can like import caret, for example. Caret is something that you use for machine learning, and so we will get into that later. But neural networks and machine learning is kind of like the focus of our next couple of chapters. And so this is like how we're going to be transitioning. We're going to be downloading Jupyter Notebook. And I'll show you guys how to do that.
I already have it.
You already have Jupyter Notebook? You already have Jupyter Notebook?
Yeah, I downloaded Anaconda.
Yeah, okay. So sorry, just record everything from here on out. Yeah. Oh, you mean you can't do any of the trinket work? Oh, that's unfortunate. Do you have another device where you can record it, and then on another device can you just like do? Oh, that's gonna be hard to do. Do you have more than one computer at home? Ah. Okay, so well you have direct access to the recordings, so obviously you don't need to be taking notes as much so you can always rewatch the recordings. So that's good.
Also, my computer doesn't have that like the inequality sign.
Sorry, what?
It doesn't have the inequality sign.
Inequality sign? What do you mean? You mean the operator where it compares like this not equals to?
What? The one with the equal sign with the dash. Slowly seconds split it.
Equal sign with a dash? Well, what would that be? I don't. That's not. I mean like this?
No. You know the equal sign?
Yeah.
Yeah. It's the equal sign with a dash. Like no, not a dash. I'm sorry, not a dash. A slash through the middle.
An equal sign with a slash. Not in Python. Not equals to is uppercase equal to. That's the not equals to operator.
Thanks.
Yeah. It's not this. It's not this. It's just exclamation mark equal to. That's what the not equal to means. Okay. So I think we can begin now. We're kind of a bit late. So hi, my name is Prahlad Bhat, and welcome to our. I haven't even kept track anymore, honestly. This is like our 10th. We have like 3 classes per week, 3 or 4 classes per week. So that's like 6. So this is our 7th or 8th class. Okay. So yeah, it's been a long time, and we still have a lot more to go. I'm very excited to continue teaching. So again, so we went over those things, right? I know you guys haven't been able to access the trinket, and I'm really trying to make sure that you guys have access to it, but apparently it won't let me. So for now, I think I'm just gonna continue just screen recording, and you guys can check out the YouTube channels, and hopefully there won't be any more errors in the videos. So let's get right to learning some Python. So we've learned all this stuff, right? We've learned how to do. Let's just to summarize. We've learned what if-else statements, functions, for loops, while loops, and we're gonna get into while loops right now, just to review. Okay. So remember that we have the while loop syntax looks something along these lines. Okay. So it'll look something like this. So essentially, then I plus equals to 1. I did not explain this very clearly. I'm very sorry, because I was kind of pressed on time. I should have really just canceled the class, so I could have given a better quality of teaching. But this is essentially how the syntax works, right? You have an initial variable, and your variable is usually either a 0 or 1. So this is essentially, this is called your counter variable. In Python, this is called a counter variable. Counter doesn't mean opposite. It means literally the variable that keeps track of the number. So I will keep changing. This is not a stationary number. It's called a counter number for a reason. It keeps increasing as we keep iterating through the number. So what this is saying is, let's initialize a variable called I, and it stores the number 0. While that number is less than 10, we print that number. So we check. 0 is less than 10, right? So the condition is satisfied. Because this condition is satisfied, this piece of code runs. Once this piece of code finishes running, this is the updating step. This is the step in the code where we actually add a particular value to our I so that I increases by a certain amount. In this case, I will always increase by a certain value. In this case, it's 2. So what's going to happen is it starts at 0, prints 0, and then it basically says, hey, take this 0 and make it a 1. So what I don't think I made this very clear, but this plus equals to sign, this minus equals to, okay, these are the most important ones. I'm not going to go past, otherwise it's kind of complicated. But this essentially, in the context of this, if you translate it to simpler code, it basically is like something like this. And you can do this in Python. You can take a variable, and you can create a new variable I using a previous variable I. It's very possible. So basically, you're changing the value of I by taking the previous value of I and adding it to a number to create a new value of I. So this effectively translates to this, translates to this. Similarly, this would translate, this minus equals to sign translates to this. All right, I'll just keep that there in comments. Okay, so when we say I plus equals to 1, we're saying every time this while loop runs, increase the value of I by 1 until it reaches 10. Once it reaches 10, stop the whole program. Because once I reaches 10, 10 is not less than 10, right? So the condition will be failed. Once the condition fails, this print statement will not run. Okay, so it's very similar to the for loop, except the for loop is not. The for loop usually depends on the number of items in a list or some sort of data structure, whereas a while loop, it kind of like depends on the counter variable, how many times you want to increment it, like the maximum number. It usually depends on those things. Okay, so let's just say we actually defined a variable called a, and it actually has a list value of 1, 2, 3, 4, 5, 6, 7. All right, and just remember, because lists can contain multiple types of data types. So it can contain an integer, and it can contain a string. Okay, so let's just put this all into a list. Okay, and so how many items are there in this list? So it's 1, 2, 3, 4, 5, 6, 7, 8. There's 8 items in this list, right? So let's do something here. So let's just say I equals to 0 represents the first term in our list. Okay, so if we wanted to cycle through this entire list, but not using a for loop, using a while loop, how would we do that? Well, we could just instead of using a for number in A, instead of that, we can actually use indexing rules. Remember, or we can just do print. So instead of I, you print A of I. So then until it reaches what, 7? There's 7 items in this list. Less than or equal to. So now if we run this line of code,
maybe you have to take out in the counter variable.
No, that doesn't actually do anything with the code. I don't know.
Yeah, maybe it's the code number 7, I plus equals to 1.
Or I'm saying that.
No, this is all correct syntax. I just don't know why it's. Oh, I think this is actually. This might. not be the right interface to do this. Hold up. Oh, yeah, that's why it's all on the bottom over here. I don't know why. Okay, there we go. So, as you can see, it iterates through the entire list. So basically, this I equals to 0. So it goes from 0 to 7, and each number between 0 and 7 represents an index in this list. So if we remember, the first term is always 0, and our last term is 7, which means there's 8 numbers in our list. So that's essentially what we can do. Okay, before I proceed to some more complex data structures, does anybody have any questions about while loops?
No.
Okay, anybody else? No, we're all good? Okay, I mean, feel free to interrupt if you ever have any questions, but not too much because I want to continue seamlessly, okay? So now we've been looking at things like lists, okay? I showed you guys matrices, and that was a pretty bad tutorial about matrices. Actually, I want you guys to focus on this new way of representing data, okay? But it's actually, before I get to any of that, let's talk about one thing. Okay, so we have something in Python called packages, okay? So Python as a text editor, it only has a certain number of inbuilt packages and functions that it can do. For example, something like print, right? A print statement. This is an inbuilt function that Python allows you to do. Okay? So this is already like programmed into Python. Print is actually a very essential part of Python, as we've seen so far. But we usually in Python we usually can't really be this simple, and we need some ways to use more complex data and more complex functions that can serve our daily purposes. Especially in data science, you need to use more advanced functions. And so basically you have these things called packages or libraries, where you can actually import these packages. Okay. You can import these packages, and each package has a particular use. Numpy is a package that allows you to do a lot of manipulation of data. So this is actually a very data structure oriented package. But before you do import Numpy, you have to download it using your command prompt. Okay, so in your command, no, I don't want you guys doing this. I'm just going to show you as an example. So in the command prompt, right, you would have to do something called it's called pip install and then numpy. So what this is essentially telling you have to go to your command prompt and click this, right? What this means is we want to download this library so that Python in our text editor can actually use the package. Oh, is it Conda? Okay, yeah, but we'll get more into how to do that. But fortunately for us, if we look into supposed to show an error sign, but I don't know why it's not doing that. Okay, so basically, the good thing about Trinket is there's already a bunch of functions that's already native to this text editor. So there's already some. I just want to know where it showed that. It showed. Oh yeah, so these are the available Python modules that have already been downloaded into this text editor. Okay, so these are some of the following. So there's a lot of numeric packages. So something like random. This random package allows us to actually create random numbers. Now Python by itself cannot actually create random numbers. This package helps us do some mathematical. Provides a mathematical tool to do to create lists of random numbers. Okay. Similarly, Mathplotlib.pyplot is a very popular library. What this allows you to do is create these complex plots, and so that are not native to Python. So Python only has limited plotting functionality. This package allows you to do a lot of graphing. Okay. Similarly, math. So we've done a lot of basic arithmetic and operators, right? So math also has a lot of cool. It allows us to do a lot of more math operators than the native ones that we have in Python. But today, the one we're going to be focusing on is NumPy, and so basically the syntax of calling a module in Python is the following. So you have to do this. You have to say import. Import is essentially just saying it's almost like when we call a function in Python. In Python, when we call a function, remember we do def to define the function. We have our function, and then it has some argument, and then we make it do something like print. We make it do something like this, for example, and then to call the function, you just have to do function, right? Essentially, it's very similar to that. We're essentially we're kind of calling, in the sense, this package. Okay, and by doing that, how we do that is we say import the name of the package. So our package we're interested in is NumPy. Okay, as np. What this essentially means is we're importing a package called NumPy from our global environment, and then we're basically naming it as np. And I'll show you guys what this means. So whenever we want to call, so basically by doing this, nothing's gonna happen. So if we click import NumPy as np, nothing shows up. But even though nothing shows up here, Python has actually called this package. Now, if we want to ever call upon this package, it'll allow us to do so. So let me show you guys an example of that. Today we're going to be focusing on something called an array. This is a very, very useful method to use in Python, and I'll show you guys why we use arrays in Python. So the reason why we use an array in Python is because if we want to use homogeneous data. So we know in lists in Python, we can actually put a collection of different types of data. So it can be 3, then 3.4, which is a float, and then it can be like high, a string, right? For an array, you can't do any of that. But the trade-off is since we can't really have multiple types of data we can't have multiple types of data in one list, we can actually perform operations on all items in this list without having to use a for loop or anything like that. And creating complex data structures becomes infinitely easy. So we don't have to do any of the we don't have to create like matrices that look like this, like I showed you guys last class. Remember, the standard way of showing a matrix is it's lists within lists. So we don't have to do that anymore, and we can do some really cool things with arrays. Okay, so let's define a variable called r. Okay, are people joining my class? Okay.
This one person is waiting to be joined, and then I told him that he was late.
So let them in. It's fine. I'm not so strict about that policy. I don't know why though. It's nothing to do with me. If they join, they should be able to join. I think. I don't know.
Like, okay. Can someone let me in?
I don't know why. So you know what? I don't understand. I have classes at particular times. I don't know why people join like 20-30 minutes late. Okay, so I think we're okay to go. Okay, so we have our array. Let's just define a variable called r. And now I'll show you guys the syntax for creating an array in Python. So now, we can't just do like because an array is actually a unique data type. It's a unique type of data structure that's only native to this package. So if we did not call this package, we cannot create an array. Array is not a universal thing in Python. You have to call this package by importing it, and then you can utilize the package. And the way to utilize the package in Python is by saying np.array. Okay. What we're essentially doing is the name of our package is actually np now. The package itself is actually called NumPy, but for our specific intents and purposes, we're going to assign it the name np because we don't want to be typing NumPy. It's much longer, so we have to say np. So you can put whatever you want in here in place of NP. But Numpy as NP is usually the standard for Python. So let's create our array. It basically looks the same thing as a list. So this is how our list. So this is our array. But now you might be thinking, why? Why do we really need this if we can be doing if we can just use a list, right? We can use a list and do the exact same stuff, right? Well, that's our arrays allow you to do a lot more complex arithmetic with this, and I'll show you guys how. Okay, so let's just say we have our array, and let's just print our array just to kind of visualize how our array looks like. Is it here? Yeah, this text editor is super weird. Okay. Let me quickly go over here. Okay. So basically, when we print array, or print our array, which is stored in the variable r, it just shows us the result. It just shows us how our array looks like, and what the class of our array is. So I've been using data type, right? But actually the proper term for defining the data type is called a class. So in this case we have different classes: string, integer, boolean, numeric, everything like that, right? So actually it's called a class. So this is of a class int. Okay, so this is just to better visualize how our array is going to look like. But so let's just say, so we had a list. However, lists are actually only one-dimensional. Okay, no matter how many lists within lists we put, they're just considered lists within lists. To truly create a multi-dimensional array, you can do that in Python. So let's just say, let's just create our array 2. Okay. Let's say array dot. Okay, and then let's create a two-dimensional array. Let's practice using a two-dimensional array in Python. So we do np array, which calls from the numpy package the array function, or the array function. And then here's how we do it, just like we did in Python. So we do brace. This is the brackets. Okay, within these brackets, we define our two dimensions. So our first row is going to contain 1, 2, 3. Our second row is going to contain 4, 5, 6. So this is essentially our two-dimensional array. So if we so now let's try so now that we've looked at some one-dimensional and two-dimensional arrays, let's practice trying to call the indexes of these arrays. So if we print the value of array of 1, this is just printing this. Oh, okay. So let's print this result. And so as expected, we do 2. So essentially, getting the index is the same in an array as in a list. So we have that covered. Now to get a range of numbers in this array, we can do, for example, if we want to get the second through fourth numbers. So this is essentially with the second through fourth numbers. So let's produce that. So now we 0, 1, 2, 3. Okay. Now another thing in Python that you can do is, if you want to get the second term onwards, you can just do 1 : So that basically specifies, since there's no specified limit to the range, it'll just go on throughout the rest of the list. Similarly, if you only want the last four numbers, you can just do 4, comma, which means that it starts at the 5th number and it'll go on till the end of the list. Okay, so those are the two things you can do. So remember, you can do colon 4, which means all the numbers all the way until the 5th term. So that's 0, 1, 2, 3, 4. So 1 through 5. Okay. Sorry, 1 through 4 because it excludes the last term. And then you can also do from 4 through, there's no limit to this, so it'll continue to go on. So 5, 6, 7. And then as usual, you can obviously do the same indexing where we just find the range of two numbers. So if we want to find the range of two numbers, we can simply just do the first number that we want to find and the last number that we want to find, and then we just index through it. So 4 through 6 just produces the 5th, 6th, but not the 7th term, because remember when we do the colon indexing, it doesn't produce the last number that we want. So, and remember, we can also do negative indexing. So remember, negative indexing means that instead of going from the typical left to right manner, we start from the right and then we go to the left. So this is especially useful if our array is very long. So if it contains like 100 terms, and if you only want the second to last number, all you would need to do is just this. The second to last number would just be -2. Oh. Okay. So yeah. So if you do -1 and then colon, right, the last number will be produced because we are getting the last number. Similarly, if we do -2 colon, 6 and 7 will get produced. So basically, when we do this negative indexing, it actually starts the last number, but then it works its way left to right, no matter if it's a negative or positive number. So I think that hopefully that makes sense. Similarly, if we did -3 colon, 5, 6, and 7. So what this means is it'll start at the end, move back 3 places. So this is what this is the 0th term. So 0, 1, 2, 3. Sorry, 1, 2, 3. That's basically what that is. Also, yeah, just to quickly recap for the indexing, you know how we have the first term is the 0th term, 1th term, the first term, second term, etc. When we do negative indexing, there's actually no -0 term. So if we work our way from the back to the front, it's actually -1 and -2. I know the rules are kind of wacky, but that's kind of how it is in Python. Yeah, that's why. Yeah, of course, that would be true. But actually, some programming languages have a -0 to be the first. So Python is just not one of those languages. Okay. Yeah, but you're absolutely correct. So in Python, the last number would be just be -1, -2, then it would be -3. So the third to last term would just be -3, and then colon just represents the range of numbers. So if we start at 4th term and we don't specify the end, it'll just go all the way until the end of the list. If we don't specify a beginning term and we go to 5, that means it'll start from the first term of the list and then go to the 5th term, the 5th index. So that's essentially how the array rules work. And so let's just see how our two-dimensional, let's see how indexing works in our two-dimensional array. Our two-dimensional array. So let's just see. Sorry, not like this. let's print the result of trying to find the index. Try to find the. So if we visualize this, let's try to visualize this. When we say two-dimensional, the array is going to look something like this. Okay. Okay, so it's going to be a two-dimensional structure where the first row is just going to be this first three terms. Second row is going to be these terms. So how it works when we do two-dimensional indexing is it starts with we find the row, we assign the row first, then the column. So in our case, row is going to be separated by row and column is going to be separated by comma. So if you want to find the second row and the first column, it would just be this. So remember, 1 represents second and 0 represents the first term. So let's see what happens when we print out. So 4. Now let's see if our prediction is correct. This is the second row, first term is 4. Okay. And now, same exact rules about trying to find ranges of numbers. Let's say if we were trying to find in the first through second rows the first term. So if you could predict how that would result, if we're looking at, sorry, this is not possible, the 0 through 1 row, which means that the first and second rows, we look at the first and second rows, and we take the first column of those two rows. So the result would just probably be 1 and 4. I do not know why this is working. It should work properly. I'm so sorry, guys. It's just yeah. Once I get to the later stages of Python, I've kind of so yeah. So I think this should work. Let's see if this happens. What is wrong with this? Okay, so we have these two arrays. Is it like, okay, let's check this out. Okay, yeah, so basically what this would do is it just takes, if we don't specify the column, right, it'll just take the first two rows. So, first row. And then for the second row, it would just, yeah, I think we should get back to this. I had it somewhere. Okay, but that's, okay, for first dimensional, you guys understand how that works. For second dimensional, I don't know what happened to that, but anyways, let's move on. I'll get back to this in just a minute. Okay, so now we can also specify the type of data that we want. Remember, because in our array, the data is always homogeneous. So it has to be either all numeric or all strings or all booleans. And so here's kind of how it works. So data types in arrays are specified by the following code. We use I in string. We use the string I for integer. Okay. We use the string lowercase b for boolean. Okay. Then we use the string u for unused integer. And so on and so forth. And then obviously we have capital S for string. So it's just the kind of the so the basics. Oh, and then we also have F for float. You know, the usual stuff. So okay. So this is how we specify the type of data we have in the array. So let's just say we had an array R, right? I don't know, let's just see what happens when we take our current R array and let's try to modify it by specifying the type. So we say type equals to capital S. Now let's print R and see what the result is. Sorry, not type, D type. Go. Okay, so this is kind of how we kind of specified. I don't know why these aren't working. I think oh, maybe it's lowercase. This should do the trick. Oh. Okay, but that's basically how we do it in Python. I don't know if this is you guys are getting the same result. I thought I knew what I was doing when it comes to the syntax. Yeah, this should. So weird. Okay. So let's see when we print. Okay. And this is not going as planned. Okay, that's fine. But that's I'm pretty sure this is how the syntax works. I just don't know why the compiler isn't producing the same result. But that's basically how this works. Okay. So so we have these two. Let's just say we have array 1, we have array 2, which are both numeric. In our case, let's just say we have these two and now we can also join these two arrays together to create one massive array. So let's just we do it using this thing called, let's just say array combined is actually equal to np.concatenate. Okay, np.concatenate of, and then we specify the two arrays that we're trying to concatenate, so R and then R2. So I suspect this is because the package isn't working. That's probably why these errors are occurring. Oh my goodness. I do not. If you guys are getting the same error, I hope it's just not me. But this should work. Why is it not working? That's fine. That's fine. That's completely fine. Okay. So we have this is the syntax and it should work. I don't know why it's not working, but this is basically how you would do it in Python. So it's you call the library np.concatenate and then you concatenate these two arrays. Okay, if somebody's done it, please verify with me that I'm not going insane. I hope I'm doing this correctly. Okay, we can also take arrays and split them into divisible parts. So let's just take our original NP array, and so let's just make sure our thing is divisible in the first place. Just say we have this array, and we want to divide it into two equal parts. So we can do NP dot array split. Do that, and then you can basically define the array you want to split, which is R, and then how many parts you want to divide it into. And then let's just print the result. So R combined. Oh, sorry, R. So in our case, okay. Okay, so again, I don't know why it's doing this, but I 100% know this is the syntax we're doing it. So I'm not wrong about this. This should work in any other scenario. So what this does, it'll take the array and split it into two parts. Okay. What else can we do? Let's check this here. Oh yeah. So we can also sort our list in again sort our array. So let's just define a variable called array sorted, and let's store the result of sorting these variables together. So you can do np dot sort, and then you can just sort this. So let's just say that our original array was just like kind of disorganized. So it wasn't even sorted. It was like 3 and then 7, 2, 5, 9, or something like that. Okay, and we wanted to sort the numbers in our array. So you can do np dot sort. Just say we want to sort our array. Print array sorted, and this should provide us with the sorted. Oh my goodness. Okay. Well, apparently that's not working. So if somebody has done the code already and they're following the syntax along with me, could they please verify just to make sure I'm not going dumb or something? Okay, so that should be how it should work. The result should be a printed out array that's sorted. Maybe I didn't call the function properly. I don't know. Okay, so you can do that. So now let's look into let's try to create a filter. So another thing you can do. Yeah? No, go ahead. Oh no, this is the syntax in Python. This is how you do it. For those of you who are doing this along with me, no. This is exactly how you do it. This should be exactly followed. This is how you import functions in Python. Okay, so yeah, you know what? I'll make sure that this gets sorted out for I don't know I don't know why this mistake is occurring. So definitely for next class I'll let you guys know this. But we have one more thing to cover before we finish. Okay, so we can sort our list using the following syntax right here. This will work. So now one thing you can do, I hope this will run somehow, but you can actually sort your list. So you can filter your list based on some values. So let's just say we have our list here, array, and then we have like let's just say we have a Boolean list. Hey, this is not an array. This is a list, and let's just say the list comprises of these Booleans: true, false, true, false. Okay. So instead of like iterating through the Boolean list and being like for bool in bool list or something like that, you're not supposed to do that. Okay, for bool in bool list, and then like doing some iterations so that if it's true, then include it in part of the list. If it's not true, then don't include it in the list or something like that. What you can do is this. So you can actually just say new array equals to our old array of x. Sorry, of bool list. What we're saying is we're going to filter the data based on the value of true or false. So now if the value of if the index value is associated with the index value of this list, then it'll include it in part of this new list. So let's try to predict what values will be included in this list. So since true is our first term and 1 is our first term, 1 will be included in part of the new list. Since 3 is false, it's not part of the new list. Since 7 is true, it's part, and then if 2 is false, it's not included. So that's basically what this is going to do. Okay, so this is how it should be done. And then something what else you can do is this. You can do something like this. You can say for A in bool list. Okay? If A is equivalent to true, colon, okay, and then we just say sorry, what we can do is this. We can do a bool list. We can do this, okay? And a quick interpretation of it is just like this. So we're saying for A in basically, remember range function, it creates a list from 0 to the length of our bool list, which is just 4. So it just creates a list, oh yeah, then -1, because that'll be 3, because this corresponds exactly to the index values. So 0, 1, 2, 3. So for A in the range of numbers 0 to 3, if bool list of A, so we're just taking that value, that index value, and applying it into the bool list, indexing it into the bool list. If it's true, then let's create a new array, okay? So now we're gonna use the append function that we used last time. Remember? Let's just say we have a new array list, and let's keep it empty. We can have empty lists in Python. Keep that list empty, and this is the filtration. Basically, it'll run it through this and say if the value is true, or if the value of the term is true, then you basically say array new dot append. Remember, we use the dot append function. R of A. So what this essentially is we're saying that we're creating this new empty list, and so this is our array. This is our array, and this is our Boolean list. And based on the values of this Boolean list, if the indexes correspond to each value in this list, it'll append it to this new list. So else, if that's not the case, then we just don't do anything. Say pass. Sorry, not length, len. .24. What's on 24? Yeah. So let's just see the value of array new. Let's see how that works. Perfect, just like we wanted it to, right? So now the indexes that are associated with the true value are appended to our list. Remember, appending is just a fancy way of saying adding. So they're appended to our new list. Okay, so that's basically just a filtration system you can do using an array and a list of booleans. That officially concludes our the data unit. And I know it's been very simplistic to an extent. So I think before we dive in, I'm going to do some more complicated examples of everything we've been doing thus far. And I think we've covered a lot of the basics now, and if maybe we can go more into depth about some of the more advanced ways we can use everything we've learned so far. Maybe we try to create a game or something, and then after that we can delve into machine learning, which will be pretty cool. So does anybody have any questions?
No.
Okay, yeah, if you guys don't have any questions, you can leave.